This is first order RL circuit. Things to remember for inductors: if the I is constant or DC, V across ideal L is 0. L is short circuit. I cannot change instantaneously in an inductor, that is, the current cannot change by a finite amount in 0 time. Example, when someone opens the switch on an inductive circuit in an actual system, the current initially continues to flow in the air across the switch. The circuit when T is more than 0. The circuit only consists of L, which is here, and R. Use the KVL and then apply in the circuit, and then substitute the VL into the circuits. The detail of the calculations or determine the variables of the IT can be referred to the textbook, either Sadiku or Nelson's. The final equation will be IT is equal to I naught exponent minus R over L times with T, which is tau is equal to L over R. And you can see that the tau for the RL circuit is different compared with the tau for the RC circuit. You have to remember these equations and of course the tau. Refer to this section, you can see that the equation is divided into two areas, which is the area when T is equal to 0 or T is less than 0, and then the condition when the T is more than 0 or when the switch is start to functions. For example, if the switch is closed and then at T equal to 0, it's open. So here is closed and then here should be open circuits. And if the switch is open and then at T more than 0, it should be closed. You have to find the I naught and exponent minus T per tau by draw a circuit. So in this area, there will be circuit number 1. Here is circuit 2. In this first circuit, you can find the I naught that flow through the L. And then for the circuit 2, you can see that there is no connection in between the source. Your circuit only consists of L and R. This is the example of the RL circuit. You can see that in this circuit, it consists of the L. Here is L. And then you can see that you need to find ILT, IRT, and then VRT. So here is IRT, ILT, and then VRT. Step will be find the initial IL through the inductor, and then T equal to 0. When T is equal to 0, we assume that in 5A equal to constant currents or DC, switch closed for a long time, L appear short circuit prior to release of the stored energy, and then the current 5A is not flowing across the R. when T is 0 for a long time, the L is charging to the maximum, I max. So when it's charging to the maximum values, the L suddenly short circuit, as shown in the figure. And then when it short circuit, you can see that there is two resistors that in parallel with the L, or the line which is short. If the resistor is parallel with the blank line or with the short circuit line, you can ignore the resistor because of the currents actually is trying to flow through a branch which do not consist of resistor. Okay, because of the currents is exit from the source and then will going back to the negatives of the currents. So there is three way, for example, first way, second way, and then third way, and then current will trying to avoid a resistance. Therefore, the current is not flowing across the resistor. Therefore, when the switch is closed, this is the circuits of the L when the T is less than 0 or equal to 0. So 5 totally will flow to the L, and then the IL naught is 5 In the next step, you need to find the time constants of the circuit, which is tau. So this is the condition when the T is more than 0, and then the switch is open circuit. You can see that the circuit only consists of L and the R. Substitute the values of R and L into the tau equation here. Tau is equal to L over R and then 2 over 4, and then the total will be 0.5 seconds. You can substitute all the values from step 1 and step 2 into the equations of IL. You can see that the ILT is equal to IL naught exponent minus T over tau. So IL naught is 5 and then tau is 0.5, and then you substitute that into this equation and then these equations, and then this is the final answer for the ILT. In order to answer the second question, please remember that when the source is not connected with the circuit, the L will becomes a current source. It will act like a current source. If you cannot understand the concepts of the inductor, maybe you can draw a new circuit which is simply look like this one. So you can see that there is 3 ohms, and then this is I with the values of IT is equal to 5 exponents minus T over 2, I think. Sorry, minus 2T. So you can see that the IT is flow through the 3 ohm resistor. So his is the VRT. Okay. So refers to the diagram. You can see that IR is the opposite directions of the ILT, and then you just add the minus into the IT. So the IR will be minus 5 exponent minus 2Tm. And then for the VR, we can see that the current is flowing from the negative through the negative polarities of the 3M, so which is you can use the Ohm's law, or maybe you can use the IR. If you use the IR, it will look like this one lah. So IR here, so it will be minus 5 exponent minus 2T, and then it will enter from the positive side, so therefore you need to use the IV here, plus IV, and then substitute the IR into the equations here. So this is IR, and then this is resistor, and then the answer will be minus 15 exponent minus 2T volt.